I am Aaron Doughten with Plexus AV. I am the Director of Technology and Marketing over there. Going to be talking about a very important part of the IPMX technology stack, and that is the topic of gateways to bridge communication between IPMX networks and other protocols. So we will get started here. So obviously it's ISE 2024. So I think if you're in the Ames booth, you probably know something about IPMX and it being a standards-based approach to AV over IP, but it begs the question of the other technology and proprietary technologies that are in the AV over IP industry that have dominated it for quite a long time. And what about systems that have those technologies already implemented, or if there's systems with multiple technologies, perhaps you would like to use an NDI camera or a Dante audio system or something like that, but also take advantage of IPMX as a kind of just general standards-based IP network. So that's where gateways come in. And to kind of highlight some of those great technology ecosystems, but them being proprietary, we want to answer the question of, is it possible to bridge these different technologies and kind of make them work together so that all of the installers and distributors and integrators and stuff like that don't have to kind of get themselves trapped into proprietary ecosystems? How can we open it up and drive innovation so that anybody can pick whatever camera they want? It doesn't matter what technology it is. Just open that up so that it really kind of just drives innovation. And so IPMX is really going to, I think, push that boundary here, especially in 2024, as more and more vendors are announcing IPMX support here, even at the show. So we'll get kind of started here and talk about gateways and IPMX systems and what they do. So gateways provide that bridge between technologies. This isn't a unique concept to the pro AV industry. I come from another company called Sencor that does a lot of gateway type functions in the broadcast industry. So bridging the gap between different types of technology and compression systems, whether it's transcoding or a simple repackaging of IP packets or something like that. That concept is very common in that part of the industry, and really the pro AV industry can benefit massively from that kind of concept. And thanks to IPMX, that kind of becomes a possibility. So really exchanging streams between different technology ecosystems kind of breaks down into three different types of methods or types of things that we need to do. One of them is repackaging. And what I mean by that is in AV over IP, we have a bunch of different IP packets. Some of them are built differently, timed differently, but really it comes down to the payload of video, audio, and metadata is relatively the same and can be exchanged between all of these different systems. So repackaging is a type of gateway function that can help ecosystems kind of share data between each other. Then we get into encoding and decoding, or transcoding, if you want to look at it that way, where different video compression systems or video compression methods, audio compression methods are being used. And to translate data between two different systems, we would need to implement some kind of a encode or decode. So I will touch on uncompressed systems a little bit first. So uncompressed systems means there's no video or audio compression at all. So really this is I guess the leanest, easiest, lowest latency version of a gateway. This is where the repackaging comes in. So we are then using either a software or a hardware-based gateway to then receive the streams, unpackage that content to their most basic layers. And by basic layers, those essence streams, the video streams, the audio streams, those metadata streams, and then repackage them into the network that they'll be going into and transmitting them into that different system. So it's a very lightweight process in terms of actual overall processing. Doesn't add a lot of latency or actually a lot of processing power. It can require a lot of bandwidth, so maybe 10 to 25 gig ports to be able to support multiple 4K uncompressed streams or something like that. But in terms of overall processing ability, it's fairly lightweight. And this is just a really high level workflow diagram going between NDI and an IPMX media network. So there you see the NDI package is being unpackaged to its most basic video and audio and metadata essences, and then packaged in the TR10 -2, 3, and 4 to be then sent into a video workflow, audio workflow, into a production network that could be IPMX. And then one of the other topics, which is interesting to us, at Plexus and then also Sencor, is the exchange of IPMX to 2110, and what does that actually take? And really what that is, being that the technology stacks are actually shared, at least a little bit, between IPMX and 2110, this really is bridging the gap between the two timing systems and not necessarily doing any kind of special sauce with the video or audio, just because PTP is the timing mechanism in a 2110 network. So PTP is a very stringent external time clock that everything in the network is actually tied to, where IPMX is a little bit more relaxed and doesn't necessarily have to use PTP. It can use PTP. But if there isn't PTP present in the network, we can actually use RTCP packets, which are kind of a side carrier to all the data that then describe the timing and media clocks and stuff like that, so that individual devices and processes and stuff like that can sync up with each other using this side carrier of data. So the gateway function, that device or software function in an IPMX network, can actually just do the retiming. So one side would need to connect it to a 2110 network and be paying attention to the PTP. And then in the IPMX network, instead of doing any PTP, it just generates the RTCP packets, and that way everybody can play nice together. So then shifting gears a little bit, you talk about compressed systems. So this is light compression or even high compression for the video and audio essences. And so this is a little bit heavier lifting because you're actually having to do some kind of video and audio compression and decompression. So this requires decode, transcode, or encode. And depending on the video codec and audio codecs, the latency can kind of vary, which I will get into a little bit here in the next couple slides. So light compression would be referring to video codecs like JPEG XS and NDI high bandwidth. HD video and 4K video bandwidths can be low to quite high, 100 megabits per second, kind of all the way up to 8 gigs if you're doing 4K light compression. But the wonderful part about light compression is its latency. So anything from half a frame of video to 30 milliseconds can be a full encode decode end to end. So still very high quality, lossless, without adding a lot of latency with these types of protocols. Now, on the other side of that coin is the high compression algorithms. Then you have ABC, which is H.264, and HEVC, which is H.265. These higher compression codecs means more latency, but also way, way, way lower bandwidth. We're talking like megabits per second versus gigabits or hundreds of megabits per second. But again, you're adding quite a bit more latency, about 10 times more latency, and seeing an end-to-end encode decode to about 300 milliseconds. So this changes that gateway workflow ever so slightly by introducing a decode function. So there you're doing the unpackaging like you were doing with the uncompressed system, but then you're actually doing a decode. Now, whether this is an FFmpeg, HEVC, H.264 software library, or some other kind of decode mechanism or IP core or what have you, needs to do that actual decode to those video and audio essences, and then we can put them in TR10-2 and -3 packages and then output them into an IPMX network. And then on the flip side, we could ingest IPMX and then take those video and audio essences and then encode them either using like an NDI SDK or some other type of compression or transport mechanism, and then repackage them into that other network. So now that we've relatively solved the video, audio, and metadata problems and being able to do that gateway function, there's also the management and control piece of it. So the control plane in IPMX is NMOS, which obviously allows us to discover, register, subscribe to streams, all of that wonderful stuff. But how do you make NMOS work with some other proprietary type of control system? This is probably not the easiest answer, to be honest with you. Just because the IPMX environment, you can't really translate directly, or at least that hasn't been written as a part of the standard. And it might be even very complicated to do so. But really what this does kind of falls on the vendors to really write drivers, I think is kind of what the problem is. But to be able to do NMOS to either some kind of unique control API or proprietary control API might be needed in order to convert between one technology and another. And then for something completely different is the exchange between geodiverse systems. So this gets into actually streaming over the internet with protocols like SRT and RIST. And so software gateways can adopt these libraries like RIST and SRT to be able to package IPMX and transport streams and all different kinds of transport mechanisms and package them in a way or protocol that can be transmitted over the internet very reliably. These types of technologies use really cool packet replacement technologies, ARQ, FEC, different kinds of buffering methods and stuff like that to be able to protect content that's being transmitted over the open internet. So these technologies allow you to kind of transmit to geodiverse sites. If you have multiple college campuses or stadiums, or you have a remote production site from a stadium to a remote production facility, you can use SRT or RIST to package that content and reliably use public internet connections to transmit that data. Yeah, so thanks to IPMX, we can actually utilize all of these different types of proprietary and open standard technology ecosystems, which really allows, I think, the industry to be able to continue to innovate, be able to retrofit existing systems with IPMX technology, and yeah, and just kind of build a better industry on the foundation of IPMX. So, thank you. Thank you for listening.